Guys, we are here to solve a very interesting Leet code problem, that is minimum increment to make array unique. Here in this problem, we have been given array of length from 1 to 10 to the power 5, and it will contain elements that will range from 0 to 10 to the power 5. So in this problem, what we do, we have been given array, we need to make all the array elements unique. Now we can have only plus one operation that we can perform on each element at a time. So in this first script, there is given 1 to 2. We need to make all the elements so we can perform plus one operation to either to any of these two. So we can do 1 2 3 or 1 3 2. So it will be now it will be only one operations, because if I plus one, if I do plus one with this two, so it will be 1 3 2. So it will become all unique. And if we do plus one with this two, uh, this two, so it will be 1 2 3. So all the elements are unique. In single operation, we can make all the elements unique. Now let's take the second test, which is a bit critical. I have written a diagram of it. So if we, let's say this is the test case. Now if I perform plus one operations for on this one, on this fourth index element, so it will become 2. And in the next stage, if we perform plus one operation on this 2, on this 2, it will become 3. Now with this type of operation, in the last stages, we are able to get all the array elements unique. Now we need such six type of operations to get all the array elements unique. So this is how the problem statement describes. So how to solve this problem? So one thing that come to our mind, that why not sorting the entire array? So because it will be easy to track all the duplicate ones, right? So how to do? Let's say 1 1, after sorting it will be 1 1 2 2 3 7, right? Now let's start iterating from the index number 1. Now if we compare these two values, obviously they are both equal, so I need to increment these elements by 1. So after an increment operation, it will be 1 2 2 3 and 7. The number of count is 1, right? So we perform only one operations, so the count is 1, count of operation is 1. Now the current, the in my index is at this element. So now if we compare this element with the previous one, so this is again it's a duplicate. So what to do? We can increment this one, right? So what to do? It will be 1 2 3 2 3 7, and the number of operations performed it 1 plus 1, that is 2. Previous one plus 1, that is total 2 operations needed till here. Now my pointer is at here. Now have you seen one peculiarity of this problem? I already have sorted my array elements in ascending order. So all the array elements will always be greater than the previous elements. But here is a different thing. Here two, this element is smaller than the previous element. So it's a bit odd, right? Don't you think? Now why is this so? Because we have performed our operations on this part of the subarray, right? So so we got something, we got a case where this element, current element, is smaller than the previous element. So it also means that there has to be element like this two in the sub part, in the subarray part. So if this condition arrives, so we will know that there is a duplicate two present in the previous subarray. So what to do? So in this type of scenarios, we can do one thing. We can compare the two consecutive elements, that is 2 and 3. I need to make this 2 equal to 3, right? So how many steps needed? To make this 2 equal to 3, we need 3 minus 2, that is 1 operations, right? And so it will become 1 2 3 3. Now I need to surplus this 3, right? It has to be greater than 3, so plus 1 for it. So it will be 4, correct? So it will be 4. So it will be 2 plus 2. These two operations earlier and these two operations. currently. So it will total 4 operations right here. And this element will be 4, correct? This element is currently 4 because we have added 2 with this 2, because we need two operations. We need to perform plus 1 operation 2 times on this 2 to get it to 4, so that all the elements up to this sub-array part is unique. That is it. Now let's go to the next index, that is 3. Now 3 is again smaller than 4, the earlier subcase. That means in this previous subarray, there has to be a 3 like this 3 present. So yes, there it is. There, if we look carefully, there is a 3 duplicate 3 present in the earlier subpart. So what to do? So I need to make this 3 equal to 4, and it will be done in single stage, single operations, that is one operations to for this 3 to become 4. But I need to make this 4 surplus this 4, because I need to make this subpart unique, so I need plus 1 operations for this thing to surplus. So it will be count 4 plus this 2, right? So it will be 2, so it will be 3 plus 2, that is 5, because I need to perform plus 1 operations 2 times on this 3 to get this 3 to 5. So now this subpart is all unique. Now my current index comes at 7. Now this 7 is friendly with other element, because we already have all the elements unique, so no need to think for this 7. So finally we have all the elements unique by using 6 operations. This is a bit tricky for me because I went to a lot of discussion pages to understand this problem. So let's put this up approach. Let's sort this array. Let's iterate from now. I need to iterate from one first index so that I can track the previous one. So let's compare the current one with the previous one. If this is a duplicate, so I need to increment this current element by 1, and I have done one operation, 1 plus 1 operation with this element, so it will be counted, right? So plus plus operations. Now this first condition was very simple. Now let's take about the second case, that is else if nums of I, if less than nums of I minus 1, that is we have some elements which is less than previous. So what to do? Let's count the difference. Let's count for nums of I to become nums of I minus 1, we need diff amount of operations. Let's increment the nums of I uh, with this diff plus 1, because I need to surplus this element, right? Nums of I minus 1 elements, so plus 1 for that. Now I need to count this thing, right? So plus equals to diff plus 1. So here is my, let's state this. Yeah, my test cases got passed. Let's submit. It's a very good problem, actually, very greedy problem. Greedies are actually very good problem. Very good problem. Yeah, all test cases passed. Yeah, accepted. The time complexity of this problem is will be order of n log n, since I have sorted the entire array, and the space complexity will be order of 1. I haven't used any extra space. Yeah, that is it from me, guys. And it was a very good problem. Please, I suggest to please go through this problem, and you'll find this, you'll enjoy this problem. It's a good problem. And that's it from me. Thank you.